Wright. I get the wonderful honor of being between you and drinks at the end of a long week. So thanks for sticking around, and really enjoyed hearing from Ben. That was some awesome input on what to expect when you get to day 2 ops. Also wanted to thank the CNCF for coming together and pulling together this day, which is the beginning of a long journey that we're on, building this community around understanding what it means. As you saw on the panel earlier today, we're still figuring out what it means to build infrastructure and deliver cloud-native apps. So I wanted to talk to you a little bit today about bringing these the innovations behind the technologies, or bringing this technology into the enterprise, something that we do at Red Hat. It's what we focus on, servicing our enterprise customers. So, see if I can operate the clicker. You hear a lot about disruption, and software is eating the world, and more importantly, open source software is eating the world, and what that means to different kind of enterprises in the industry. On a certain level, people are just learning how to become software companies. So this is kind of a lengthy quote from the CIO at Ford. Ford's not somebody you would immediately think of as a software company, but they're, from an infrastructure IT perspective, they're really refocusing themselves to think about, the way I put it is IT transitioning from a cost center to a source of really differentiated value in the industry. Like, how do you build yourself as somebody different from all the players in your specific industry, especially in the context where the sort of traditional businesses, the brick and mortar type businesses, are potentially being completely turned inside out and upside down by new players who have a very software-centric view of the world. So to me, this is heavily led by open source innovation, and it really is looking at where we were 5-10 years ago, really pushing open source as a commoditization concept and lowering your costs, because IT, well, it's a cost center. 2, open source is the place where we're doing innovative work, and that's what you want to leverage when you're looking at IT as a source of your differentiated business value. So the buzzword compliant part of this is digital transformation. You hear a lot about digital transformation. Analysts have all their different ways of defining it. Again, this is about driving business value through your IT infrastructure. More and more at the top of mind for CIOs, this is a survey that we did, and trying to get some insights into where the heads of CIOs are right now. And so they're looking at how can they show business differentiated value from their IT departments. How can they do that while managing security and being traditionally risk-averse departments, managing risk. It's really important things top of mind to the CIO. You don't want to be the next Wall Street Journal article showing how you've been hacked and leaked out a bunch of credit card information or other kind of critical information. And in order to support these, this sort of transformation or this journey, building up a new set of skills and infrastructure that enables these modern architectures. So here we're talking about cloud native, whether that's microservices, containerized applications, or even just some kind of API-driven infrastructure, giving themselves the capabilities to actually build the next generation IT systems that they need to help keep their businesses functional and alive and healthy. So one of the things that we see just from talking to all of our customers, and something that I like to highlight when you're in conversation with any one particular kind of industry vertical, is this is common across all of the industry. It's not just an issue that you see in the public sector, or an issue that you see in retail, or an issue that you see with telcos. This is something that's common across all these businesses. And while they do have business-specific needs, maybe it's a compliance requirement or a specific set of SLAs around network processing in the telco case, that specialization is important to understand, but it doesn't mean we need to write something fresh from the ground up for each industry vertical. And in the past, there's been a lot of temptation and businesses that have grown up around that. But today, and part of the power of open source, where we bring people together, we collaborate and build these more sophisticated systems, architected to extend and be able to take on these varying kind of requirements. I think that's really an important message to get out, to make sure we're collaborating together and bringing as much of the industry together to focus on solving problems together. And at the bottom of all this is this infrastructure modernization that's helping these businesses adapt to the business demands that are feeding this sort of sense of urgency. As a technologist, it's really tempting to just get enamored with technology. And I think we do a disservice in general to the industry when we over-focus on just technology. We're developers, at least my background is coming from being a developer. Developers at heart, you're focused on writing code and using technology to solve problems. Donnie touched on this morning. It's not just about technology. There's a really critical component from the DevOps movement that recognizes people and process actually really matter. So you can have a pipeline, kind of not a CI/CD pipeline, but just a conceptual pipeline of activity that starts with developing your software and ultimately deploying it, that has a lot of arcane processes involved. You've got different groups that throw things over the wall and don't speak with each other. And the end result is every one of those touch points along the way is a stall point. It's a queuing point if you're thinking about network queuing, or it's a place where things are going to slow down. And so, recognizing that this is a big part of your efficiency gains is really important, and that you can throw any amount of technology at the problem, but if you're not really focusing holistically on solving that problem, you're not going to get there. So IT must evolve, and that's people, process, and technology. I think we've seen a lot of this kind of concept. I like to think of this in 4 parallel streams in terms of IT evolution. And one of the things that I think is important to look at is, if you look from a kind of development process point of view, waterfall through to DevOps, or an application architecture, client server, multi-tier apps, microservices, each of these different forms of evolution are taking place to some degree in isolation. And I think what's really special about right now is the confluence of all of these ideas coming together. And this is why we're seeing it's in some cases it's repeating ideas, but it's the fact that they're happening at the same time that really makes them powerful. So on the cloud side, you have API-driven infrastructure. You could still be deploying virtual servers, multi-tiered apps, and using a waterfall methodology, and you're going to gain some level of efficiency. So standalone, just having API-driven infrastructure is beneficial. And you can think of that in any of these dimensions. Each one of those have some standalone efficiency gain. It's the confluence of these streams that really brings the fundamental change that I think we're seeing right now. And to me, that's what's exciting. So brief digression, I was in Australia recently, and I was talking with some customers. And we're actually talking about this topic, cloud native, and how do we help them get adopting new technologies and transform their IT departments to help support those needs from the lines of business. And completely independent, these 2 different customers are, through me, arguing with each other about who has the older mainframe in Australia. And these are mission-critical systems, one of which the last time they touched the software, I think, was 1978. Handling a large number of transactions. And we're sort of struggling with this. On the one hand, everything is new and we're trying to move fast. And on the other hand, we have real critical systems that are part of large enterprise infrastructure that actually aren't going to change, or at least not change quickly. And so there's some design patterns that we can derive from those requirements that can help us understand how do you isolate the fast-moving part of your application from something that's essentially static, although critical. So I think it's important to keep that in mind, keep that context in mind when we're talking across the industry about how we're going to move and change and innovate in the IT department. So my sort of hypothesis here is that change is constant. And with constant change, Your technology choices are point-in-time choices. It's your mindset, your process, your how do you manage and adapt to change that really matters. So how do you build in this environment of constant change? And to me, this is sort of a simple thought experiment that applies both to the application tier as well as the infrastructure tier. So the infrastructure as a code concept, we can be doing the same things as we're developing, deploying, and updating the infrastructure. And critical to that is always having some level of insight, analysis, so that we're drawing data out of the infrastructure or out of the application to understand how it's operating and just iterating and always improving. And it's this kind of thought process or internal process that really allows us to adapt, because change is what's constant here. If you look at a traditional application stack, we had hardware at the bottom, an operating system, and you had a set of applications written to low-level system interfaces, system libraries, system calls, things like that, and a lot of systems-level programming. Turns out that's not sort of available to large-scale enterprise developer body of developers. And so we started having additional abstractions, and a really simple abstraction is Java, a JVM, giving you a higher set of interfaces, or higher abstraction, a different set of interfaces, and along with that, a set of platform tools and messaging, middleware, all these components that start making it easier and easier for application developers to write applications. I like to think that this concept is valuable. And so while you could take your JVM and port it to an x86 natively, it's been done, doesn't necessarily mean it's a great idea. And so these abstraction layers are powerful, useful, and they give there's value to each of the users at each of these levels. In a modern sort of world, this same principle, I think, holds. And that's the hardware level. Now we're talking about a data center-wide pool of hardware. You have some resource management at the bottom, some infrastructure management or virtualization layer, potentially. There are virtual machine primitives associated with that virtualization layer. They're useful for certain types of tasks. But there's also an application orchestration tier that makes it more accessible to a different set of developers, specifically running containerized applications. And again, it's just a box diagram, so it's easy to make things look the same. But I think the point is that there's different tools for different jobs. And one of the things that we hear from our customers is confusion about why are we making a change, because it sounds an awful lot like what we just did, virtualizing ourselves. So we're really trying to help articulate the difference between why you should care about application orchestration as independent from resource management. And I'm using this sort of operating system JVM analogy as a way to kind of make it really accessible. Hopefully that resonates with you, and if you have a better one, I'd love to hear it. And I think what we're getting at here is that perspectives matter. So you have a really critical persona, which is the developer, and another critical persona, which is the operations team. And even with the DevOps movement, we still have different roles and responsibilities, and therefore we care about different things. And from the developer point of view, it's very much about the application. From the operations team, it's still managing infrastructure and ensuring resources are being utilized and understanding what's happening with faults, potentially in that orchestration layer, because now that's what they're responsible for. And the end result of that sort of differing views of requirements is focusing again on separation of duty, which is that similar to that Java to application orchestration diagram I was showing before. And this specifically, we're talking about OpenStack and Kubernetes from a Red Hat point of view, but the point isn't, it's not the technology choices, it's just the abstraction layers, and really helping people see that there's value in utilizing the abstraction at each layer. I think sometimes we get confused because there's a lot of amazing open source projects tackling problems in slightly different ways, and we see there's temptation to grow up or grow down in functionality. So again, just because you could port a JVM to an x86 bare metal, maybe that's not the best choice. So OpenShift is a product from Red Hat, and that's something that we're really proud of. We're building that out of some core technologies. Certainly Linux is at the base. Docker is a core component for the container engine. Kubernetes for application orchestration, some additional logic to help improve developer efficiency so that you can start with source code, push your code, go through a CI/CD pipeline, ultimately deploy your code, have that code be deployed across a large scale pool of infrastructure, and manage all of the load balancing, application level routing, et cetera, and having registries and persistent storage and all the things that actually make a system work. So this is something we're really proud of. And what I think is really cool is how we can learn from our experience and share that with other people in the industry in a place like CNCF to really help advance the state of the art for the entire industry. So we're active in OCI, trying to help standardize the runtime and image format for containers. And then, as we were talking earlier today, whether it's standardization, best practices, sharing of information, taking those core building blocks and expanding that into the entire infrastructure needed for cloud native infrastructure to build out an industry understanding through combination of open source development and some level of standardization. What does it mean to bring all these things together? Here at CNCF, we have been able to, we've been blessed with an awesome gift, which is a 1,000-node cluster. Actually, I don't think it's quite 1,000 nodes yet, but it's growing quickly to be 1,000 nodes. And so we took advantage of that cluster to run OpenShift on the cluster and just experiment with what scaling looks like in that environment. Actually, I wanted to say one other thing. This is the Cloud Native Computing Foundation initial charter architecture diagram. And you heard earlier today that we weren't quite in total agreement over exactly what this architecture diagram looks like. So think of this as just a placeholder, but it does call out some of these different layers, different notions of orchestration versus infrastructure versus that top level application definition that we talked about earlier today that I think is really important and trying to help define some of those distributed services. Now, the scale testing that we did with CNCF. So first, a big thank you to Intel and Switch for putting together this infrastructure for us, and of course the CNCF for hosting it. Our goal was to scale OpenShift to 1,000 nodes. We actually used 300 physical nodes, so we virtualized the infrastructure using OpenStack and then ran OpenShift on top of that. We learned a lot out of this process, and we were really happy to be able to share that with the community. I have a link in here that links to a blog post that we put on CNCF blog posting 2 days ago. I definitely want to thank Jeremy, who I think is here, and the rest of the team for a lot of work that it took to run through some trial and error, discovering some of the challenges with just getting this infrastructure working, because it hasn't been utilized, I don't believe, to the scale yet. And one of the things that I think is cool is I'm running out of time here, so I won't go into too much detail over what the internal architecture was of the deployment, but one of the things that I think was cool is the outcome. And what this is just a list of the bugs that we found, filed, and either resolved or in the process of resolving as a result of trying to scale up the system to that size. And you can see it's spanning across a number of different projects. We found issues in Kubernetes, we found issues in Docker, we found issues in Ansible. We were using Ansible and discovered a performance regression that was really important for us to fix. So you see that using this hardware resource, something that we have at the CNCF to do this kind of scale testing, where we were focused on not just kind of micro benchmark how many containers can you launch within a period of time, but trying to look at it more comprehensively from a realistic use case point of view. And one of the things that came out of this, or that's driving this, is the cluster loader, which is an open source project that we use to kind of generate the load for this system. And that's something that we would be happy to share with the CNCF, or at least give you pointers to it on GitHub. But the outcome of this, again, is touching a lot of different subsystems and helping us understand the challenges and then advance the state of the art for the industry. So I think that's really all I wanted to share with you today. Again, thank you for coming, and I think we break right after this for drinks, and love to have any conversation with anybody out over a nice beverage. So thanks again.